All right, now we're going to talk about the second rule of differentiation. Well, maybe the third rule, depending on you look at it. We talked about in previous videos of the power rule. The power rule. And that's when you take the derivative of a function, all right, it is a power function. And that's going to equal n times x to the n minus 1. All right, and I can use the real power functions. Very, very powerful rule for differentiation and finding derivatives. We then talk about the product rule. The product rule. The product rule is when you have two functions, all right, that are being multiplied together. So if you have dx and you have u and v, all right, that would be the derivative of u times v plus the derivative of v times u. That is the product rule of differentiation. Well, now we have something called the quotient rule. The quotient rule, and that is when you have a quotient or you have the division of two functions. And what do you do here? Well, this is where you're going to have same very similar thing that you have with u and v. All right, is that you're going to set up a table of u and v. And what you do with u is you're going to take the derivative of u, and then you take the derivative of v. And now what you're going to do here is you take the derivative of the top function, which is u. So you're going to take u times v, and then minus, not add because you're dividing. I always think of like powers, and when you divide, you always have a negative exponent, all right, right here. So I remember that's where the minus is. And for product, you always add your exponents to the top. That's how I remember it. So when you have that, so it kind of goes back to the power rule. This helps me remember. All right, but then you take minus, all right, dv times u all over, all right, the bottom squared, v squared, all right, v squared. And that is what the, all right, quotient rule is. Some people say it's going to be, all right, low d high minus high d low over low low. All right, I don't really care, but that's how we can help you out right here. So with that, my friends, we're going to go through this little problem, and we're going to have several different problems of using, all right, the quotient rule. Now, the quotient rule, unlike the product rule, kind of has to be done. All right, we have one function on top, one function on the bottom. We are going to take this right here, and we realize that our top function, that's our u. So u is going to equal, in this case, 3x minus 7. All right, then u prime, or du dx, is going to equal 3. Our v is the bottom function, the one in the denominator. All right, and that in this case is x squared plus 5x minus 4. And then we have v prime is going to equal, using the power rule, 2x plus 5. And we got that. So hopefully we're helping you with power rule as well when we're going through and doing this. And so to use the quotient rule, we're going to find h prime, this derivative, by taking, all right, high d low, or low d high. So we're going to go derivative of the top, which is 3. All right, times the bottom, which is going to be x squared plus 5x minus 4. Minus, because we're minus, and we're going to go, all right, high d low. So we're going to go 2x, so it's v prime, derivative of the bottom, which is 2x plus 5, times the top, which is 3x minus 7. All over low low, or the bottom squared. So in this case, we're going to have the quantity x squared plus 5x minus 4 squared. We can simplify this if you wish, but I'm just going to tell you to save time. I usually don't simplify. I know I'm a bad teacher, but that's what algebra. So generally, if you got an AP test or you have to write this out, I would just say write it out. If you have to plug in a value, maybe simplify, it makes it easier to do. But that is our derivative. That's it. We can write that out. Big, long, and messy, but that's what it is. Well, let's try another one. Okay, so here we have, this is actually example number 2. Okay, we have y prime we want to find. We want to find the derivative of this, so I want to find y prime. So find y prime. Notice that we have the product of two functions. So what would I do? Well, you could use, all right, well, we need to use the quotient rule because we actually have, this is going to be our u, and this is going to be our v. All right, and so if I have this right here to find y prime, my u is going to be x plus 1 times x plus 2. Now, to take this derivative, I would have to use a product rule. But I don't like the product rule because it's really long and messy, so I'm just going to distribute this through and make it a little bit nicer, and that's what I would do. So I'm going to make this x squared, all right, plus 3x plus 2. That makes my life a lot easier. So I know the derivative is going to equal 2x plus 3. Not good? Looks good. Now, right here, I'm going to move this over a little bit so I have a little bit extra room. There we go. Now from here, I'm now going to take my v. All right, my v. Change color. V, once again, equals x minus 1 times x minus 2. If I wanted to find v prime, I would use the product rule. But I don't want to use the product rule because that's long and messy. So I'm going to use algebra because algebra is your friend. Is your friend. Sometimes a friend to me, but it's your friend. So use algebra appropriately. In this case, we are. So we're going to have x squared minus 3x plus 2. Find that derivative. It's going to equal 2x using the power rule. 2x minus 3. Ta-da! All right. So from here, my friends, we're going to find y prime. Y prime then is going to equal the derivative of the top, which would be u prime times v. All right, so we're going to have the quantity, all right, 2x plus 3. And I can write this out, but I'm going to write my simplified one because it makes it a little bit nicer. X squared minus 3x plus 2 minus the derivative of the bottom times the top, all right, which is going to give us 2x minus 3, all right, times u, which is x squared plus 3x plus 2, all over the bottom squared, all right, and that's going to be, all right, the quantity x squared minus 3x plus 2 squared. That's what we got. You can simplify if you wish, but that's going to be our derivative. We found y prime. That's the quotient rule, my friends. All right, we're going to do one more. So how do you solve this? We're finding y prime. This also equals y prime, so dy dx also equals y prime. Well, once again, you see you have a quotient function, and there's a bunch of different ways you could solve this. We're going to see this. We have u and we have v. So yes, you could use the quotient rule. So going through here, we can say, okay, u is equal to, all right, x minus 1 times x squared plus x plus 1. And if I want to find u prime, I would take the derivative of this, u. But that is the product rule, so I'm going to simplify this to make it a little bit nicer for myself. And so we have right here is going to be x cubed plus x squared, all right, plus x. It's going to be minus x squared. It's going to be minus x, and it's minus 1. If I combine my like terms, my friends, we'll have x cubed. All right, these cancel out. Boo, boo. All right, these cancel. Boo, boo. Minus 1. Oh, that's so nice. That is so nice. All right, and so what do we have for u prime? U prime is going to equal, all right, 3x squared. Then I go over here. All right. And I probably should go over there, so I apologize. If you write it out properly. Move on over, move on over. And now we have v. What is v? Well, v is this little x cubed. And so we have v prime is going to equal 3x squared. And so once again, using the quotient rule, because we have the quotient u over v, all right, we're going to find out y prime, which is also equal to dy and dx. And what we have is going to be low d high. In this case, it's 3x squared times x cubed minus quotient rule, v prime, all right, high d low, which is 3x squared times the quantity x cubed minus 1 all over low, or the bottom squared, which is x cubed squared. Ta-da! And that's what we have. And yes, you can simplify this to x to the 6th, and that works out just matchingly. Now, I'm just going to say, if you looked at my other slide right here, I said algebra is your friend, and when you're doing problems like this, algebra is your friend. If you can avoid using the product and quotient rule, like over here, we do. Well, on the same token, notice how we have one term right here. If you can simplify this, we know the top simplifies to x cubed minus 1 over x cubed. If you want to simplify this, I would actually write this as x cubed over x cubed minus 1 over x cubed, which actually could be simplified to 1 minus x to the negative third. If I wanted to find y prime, if I have simplified all this, that's just simply going to equal the derivative of this new simplified function, which actually equals, all right, negative 3x to the negative fourth. And what we have right here is going to be 3 over x to the fourth. And that will be simplified. How can I verify that? Well, I'm going to do it right now. 3x to the fifth, all right, minus, all right, we got 3x to the fifth plus 3x squared all over x to the sixth. And hopefully you're following along with me and maybe fast forward this. I don't know. Cancel, yahoo! And we have 3x to the, oh my goodness gracious, 3x to the fourth. That is the same thing right there. We matched them up, combined them. So, algebra is your friend. If you're able to, with these type of, all right, polynomial or rational expressions, if you can simplify them in the beginning like this and just use the power rule, please do so. That's what you can do for many of these expressions. Well, not necessarily this one, but not necessarily this one as well. But there are times and places to use a quotient rule, my friends. All right, this one, yes, quotient rule. This one, algebra is your friend, then quotient rule. This one, you could do all algebra if you wanted to. All right, I have one more with the quotient rule, and we have this little problem right here. So if you want to pause this and try this out before I go through the answers, this one we're using some notation and find the derivative at x equaling 0. So we're finding actually what is the slope of the curve at this particular point. We're given our different values for u and v. I had one similar to this with the product rule. Okay, so how do we solve this? Well, I have these are two different ratios. All right, we're in two different quotients. So we're going to solve this by saying, okay, the derivative of this, we're going to use the quotient rule. So we're going to take the derivative of the top, which would be v prime times u, minus the derivative of the bottom, which is u prime times v, all over the bottom squared. For this one, it's a little bit different because now we're going to take the derivative of the top, which is u prime times v, minus v prime times u over v squared. It's not x squared, v squared. Now, in each one of these cases, okay, you will get a different answer. Notice how there are different things because we're taking the derivative of different functions. So there are different answers depending on the quotient you have and the functions you have as well. And so how do we solve this? Well, once you write this out, now we're going to plug in the values for u. So v prime of u, v prime of 0 in this case, oops, is going to be 2. So we have 2 times u of 0, which is 5, minus u prime, which is going to be negative 3, times v of 0, which is negative 1, all over u squared. U squared is going to be 5 squared. This will be different over here. If we did the same thing, we have u prime, which is negative 3, times v, which is negative 1, all right, minus v prime, which is 2, times u, which is 5, all over v squared, All right, so v squared is going to be negative 1 squared. And so what we have then, if you simplify, it's going to be 10, all right, minus 3 over 25, which equals 7 over 25. This one right here is going to be 3 minus 10 over 1, which gives us negative 7. So two different answers because we have two different slopes of two different functions, but both are finding the slope at 0 in this case. All right. Well, I hope this helps you out with the quotient rule. Hopefully you can do your problems. We're going to use this with trig functions in the future. All right. So good luck and God bless with the rest of your problems.